Okay. So I suppose you all are seeing that. So this is the syllabus we are going to cover. So today is just a part one, but we are going to cover a lot of topics as part of this series. So we're going to start off as in today, what is DevOps, what is DevSecOps, and then we're going to see what couple of tools in here like GitHub, Vagrant, and probably Ansible. Yeah, but rest of those will be taken care in the next coming sessions. And then we'll also talk about what is secure SDLC and how it fits in CI/CD pipeline. Then we will have a brief introduction of what AWS is. We are concentrating on AWS because it's pretty predominant and most people use it. But if there is more inclination towards GCP, Google Cloud Platform, then we will also cover that, right? And then we'll go off and finish off some topics in container security. We'll talk about how to manage secrets, how do we do configuration management, and then we'll talk about, static analysis, dynamic analysis, RASP, IST. And don't worry if you don't know what all these mean, but you'll come to know as and when we talk about it, right? And then we'll cover what is infrastructure as security and how it relates to security. So in here, we are going to cover something called Terraform and probably a bit of Packer in there. But then we'll also cover how do we manage these vulnerabilities, which we discover as part of DevSecOps, right? And finally, we'll see how do you manage, patching in cloud. And we'll talk about patching called Phoenix methodology, and then we'll also talk about a little bit about how do you manage in CI/CDs like blue-green thing as well, right? So with that, we will share all of these links which I'm going to talk about now. It should come in your email IDs. So yeah, please do keep track of your email IDs. Now, further ado, let's get started then. Any other questions before we start? Okay. Fair enough. Let's get started. So yeah, as we mentioned, this is part of part one of DevSecOps. And since Raghu already gave an introduction of me, so I'm going to skip this. So yeah, so the big question is, hey, everyone is talking about DevSecOps. What is it, right? And how it's gonna help me in achieving my goals, security goals, and how it can make security, how we can make security as part of DevOps or CI/CD pipeline, right? So basically, DevSecOps, are well known as DevOps, is a collaboration of different entities in a software development life cycle. Like you have a development team, you have operations team who deploy the code, then you also have a quality QA assurance, quality assurance as well. But when we say DevOps, by its definition itself, it includes security as well. But since people wanted to ascertain that, hey, DevOps also includes security, this new term called DevSecOps came into existence. And there are other names of DevSecOps like SecDevOps, or you also will hear something called rugged DevOps. All of those mean same thing. Like they all mean DevSecOps. And if you want to learn more about what was the reasoning behind it and why it came into existence, and you can read a book called The Phoenix Project. It's a novel which takes you through different stages of a person, an IT person going through different stages of pain. Like he doesn't have any way to know what kind of systems are in the infrastructure and how which one are stable, which one are not stable. So you can go read that book. It's the Phoenix Project book, but I will briefly cover what that means is, right? So now, historically, development teams work in their own kind of a container when like they work and then they hand it over to DevOps for them for operations to deploy. But there is no collaboration between these two entities to make it seamless. So more often what happens is that only development team knows how to deploy it. then there's a lot of back and forth between development team and operation team. Hey, this is working. Developer will say, hey, this is working in my local setup, and the operations guy will say, hey, it's not working on my system. What's going on? So then they have to repeatedly go back and forth, talk about what are the differences. And we are going to talk today about one such tool called Vagrant, which will avoid this problem. Like, it's working on the problem of like, hey, it's working on my my machine kind of problems. Then let's go ahead and talk about what are the advantages of DevOps, right? The reason it's picking up so much attention and media attention is because it provides a lot of benefits which were not available before, or if they were available, they were like in a handful of companies like Google, Facebook, and a couple of unicorns like Etsy, Uber, and some of those. So it provides resilience, like, so in case you can handle a situation probably like within 5 minutes instead of waiting like a 1 hour, 2 hours, or some customers coming and complaining to you saying that, hey, something is done. Instead of that, you could deploy something like within 5 minutes. Or if you have deployed a bad artifact to the production, then you can roll it back within like 5 minutes, right? So that's what it means when we say resilience. And then it also provides flexibility in terms of what you can do, right? So you can, if you want to change your, let's say, development methodology, or if you want to replace Vagrant with some other tool, as someone called Deepthi will mention in the chat, that, hey, why Vagrant? So DevOps lets you design pipelines which are tool agnostic, right? So you can replace some tools without having a lot of efforts, because they are very flexible in terms of how we design our pipelines. Then it also helps us. Let's say, for example, one team uses TeamCity for integration, another team uses Jenkins. You can do that as well. So I'll come more about like, hey, like usually people think that DevOps means automation. It's not automation. It's just not automation. It's more than that, right? And then it also helps us to achieve reliability. And the way it does is, because you're deploying it to production or staging multiple times in a day or a week or a month, you know that this is working, this process works, and it's reliable, and you don't see any issue. So for those who code, so imagine that you developed a code like a month back, and if you come and read it again, you will not have any idea of what it's doing unless you're weekly doing something on that particular project weekly, right? So it avoids the process, those pains, like, yeah. And then it also helps us achieve speed. So the companies who follow DevOps, some companies deploy like 50 times a day, some do like every second of a day, and then some do once in a month, right, or once in a week. So DevOps will enable you to achieve all of those. Like, you can go as fast as you want, or as slow as you want. And it also matures as your company matures. Let's say you are a startup, then you might not want to automate everything, probably some part of it, because you haven't figured out your market fit yet, and you're not profitable yet, right? But as and when you move forward, you can then enable more automation, more culture, and more processes into it. Right. And then as part of DevOps, right, so we have to enable now security, right? So before this, like historically, the way the code was developed was using a waterfall model, wherein like, hey, we will gather requirement like in Jan, and then we'll start designing in February and start implementing in March, April probably, and then we're going to deploy it in June, right? And then at end of the cycle, security used to come and say, hey, we need to do pen testing. Let's do, right? And then we used to do pen testing, right? And more often, even these days, developer teams are, their timelines are very tight. So they will come to security just like a week before production. So even if we do find, like as a pen tester, security people, we do find out issues in them in the code, they don't have any way now a good way to fix them. It usually is like a patch, like a temporary patch, which will just stop the bleeding, but not the cause of the bleeding, right? And with agile methodology, this has become even more rampant. Like the code goes to production every week, right? And then the design changes every week. So you have to keep up with all the cycle. And still, I see a lot of organizations don't handle this problem very well. But with the help of DevSecOps, you at least have some flexibility and some control, and then confidence that, hey, yeah, the code which is going to production is secure. And if something comes up, I can patch it in like 5 minutes or 10 minutes based on the criticality of the vulnerability, right? So these are the benefits which DevSecOps provide. Like it is going to be stable. You have lots of control on who's let's talk about control a bit. Like usually DevOps have root access, right? In some of the companies, even developers have that. But if your company needs like SOC 2 compliance or ISO 27001 or 03, then by its nature, you cannot let developers have those control, right? If they don't have it, how are they going to fix it, right? So it's like a catch-22 position. Like you want to fix the problem, but you don't want to give access to them. But if you have DevSecOps pipeline, then even developers can push without involving security or ops into the picture. So that's what it means by control. And the accountability is that we can audit everything which is going on in the cycle. Like we can see who logged in as some user, and you can enable all those security mechanisms. Let's say if you want to deploy a code in one of the organizations which I know, you need to have 2 people give their go ahead to deploy it, right? And then in some critical infrastructure, like for example, you're handling PCI credit card data, right? Then we can define a way in which that if you want to log into the server, that you need PGP keys of 2 people before you can log in. One guy cannot log in. So even if someone wants to do something bad, he cannot. Or even if some attacker compromises it, then at least you have one more level of defense, and it's auditable that, okay, this is how it got compromised and stuff. We are going to talk about all of these in detail, and I will also show you a demo of how we can achieve all of these, right? And then we'll have confidence because we are doing it every day, right? So I forgot who said it, but there's a famous saying which says that confidence is just that having confidence of repeatability, like meaning you're confident because you have done it so many times without failing, that you're confident enough that it's going to happen, right? And then risk aversion is that now, since you're putting security in every stage of software development, then even if one security control fails, then you do have risk aversion, meaning that you can manage your risk accordingly, right? Now, this is one of the definition of DevOps, right? So it's a combination of these 4 things. Like culture, that's the most important part of DevSecOps. If you just have automation but not the culture, then your company is not following DevSecOps, right? Just like a lot of companies, I see that they have something called, they will say that we are following agile methodology, but the only thing they are doing is just stand-up meeting, right? So let's go ahead and talk about culture, automation, measurement, and sharing. So before I move forward, do we have any questions? Okay, cool. Let's go ahead and let's talk about that. Yeah. So one of the question was that are we recording this? Yes, we are recording this, and we'll include you. Hemanta, yeah, we will include your email in there. Yeah. So Deepthi was saying why Vagrant? We can use other tools as well, but I don't see any alternative of that. But it just makes our job easier in terms of automation and having your entire infrastructure as a code, or at least your development environment as a code, right? Yeah. So what, let's talk about culture, right? So culture means that instead of working in silos, like dev team working in their own silos and operations in there and security in their own, what the culture promotes is that all of us should come together and work together without having any reservations in terms of like, hey, if I go to security, my deployment will stale, because they will now say, they'll talk a lot about, hey, you cannot go to production unless you fix all of these, right? So security is known to be like blockers, and usually that's the reason why developers won't come to security if they find an issue, or if they're in urgent need. But if you have a culture where you trust each other and you know that everyone are in this game together, then there's more chances that developers themselves will come forward with the security issue saying, hey, I caught this issue, what should we do, right? So Amazon is famous for doing this, that the people who code, they have to deploy to production, right? And then they know the pain of operations. So it's a good strategy to rotate these shifts as well. Like some of the companies also do is that even if you are a developer, you behave like a support engineer to answer your customers' queries, because then you will know, okay, what kind of questions our customers and customers are asking, and then they will know the pain, and then they could keep that in mind when developing. And similarly is the case with the security. So yeah, so having that as part of culture, the security as part of culture, or a sharing as part of a culture is very important to do any kind of automation. So one such example I could give you was that a previous company where I worked, so everyone wants to have secure environment, but the culture was so that every other team was working independent of others. So no one was willing to collaborate with each other. No one was willing to come to a common ground. So then, even though they had a lot of automation, it was of no use because no one is using it, and there is no a uniform way to deploy. So every team uses their own environment, their own staging, their own production. So no one, even security, doesn't know how many assets we have, how many are under SOC 2 compliance, how many are under HIPAA, and how do I secure them. So all of that, as classic example of assets management, will also fail when you don't have inventory of that. So if you do have culture, then the automation will work. And then once you have automation, like this is what we are going to talk a lot about today, is like automation. Once you have automation, you can deploy to your production within minutes instead of days now. And then you can also measure if your automation is working or your customers are loving it, like A/B testing. And you can also deploy, let's say, security mechanisms only to a subset of your customers. That way, you know, okay, something is wrong in like OAuth authentication or some part of your code, right? And then if you change from, let's say, using AMIs, which is AWS image format, to Docker, you can quickly change it by having a different pipeline based on what kind of code is it, right? So you can do all of those, like if and else, or if this or that kind of thing. You can do that as well. Now, since we have automation now, you can measure it. Now, I believe that if you can't measure it, you cannot improve it, right? If you don't know if something is wrong, how would you even fix it? So DevOps will let you measure things. And in terms of measurement, we're going to talk about ELK stack. Like we are going to set up a SOC, security operations center, locally on your laptop, and then we'll see when developers are pushing code to production, are they doing something which opens up a loophole? Like when they are changing firewall settings or security group settings, we will see on the dashboard that, hey, someone just enabled port 22 on the internet. So we'll see that as well. And then sharing, of course, right? So when you have the culture of sharing, then people will come forward, hey, this is working good and we want to continue it. And then people will become more smarter and smarter. And this way we'll find out more issues, because now security team is not the only one who's after vulnerabilities, but everyone in the organization is after vulnerabilities, security issues, and trying to improve the posture of your organization, right? So in short, what DevSecOps is, like, they take the best practices of Dev and Sec and Ops, security, development, security, and operations, and put them together in a homogeneous, uniform process, so that everyone know what's going on, everyone has a visibility, right? And as part of these, like, some of the organization, what they do is that they let everyone in the organization know what vulnerabilities are there in our code, like, openly, right? So, and some of us cannot even imagine doing it, because we work in a very legacy kind of system, or we have very authoritarian like a culture, where, like, if you are part of if you are managers only, then you have access to it, or if you are part of this team only, then you can say it, right? But I'm seeing more and more trends where everything is available for everyone. Everyone has access to all the wikis, everyone has access to all security tools, everyone has access to all the dashboards which ops use. Thanks to the automation, now everyone knows, okay, if I do this, I'm going to give some pain to other people, so I'm not going to do it. So since you have now visibility, then you can take correcting correcting efforts to fix that, right? Yeah. So, and the goal of DevSecOps is to embed security as part of CI/CD process, and this whole software development lifecycle process. And then the critical thing here also we have to remember is that if you say, hey, I'm not going to use GitHub because security team does not know what GitHub is, then it's going to fail. Okay, so we have to use the tools which developers are using to embed security as part of those in their process, instead of inventing our own tools. Let's say, for example, you say, hey, we have to run IBM AppScan, right? But that doesn't support your development tool. So we are going to spin up another box or something, and then we are going to do it. So I'm sure there are cases, but we should try to purchase tools, or develop tools, or at least scripts which will consume the tools which don't which can't fit in development tools. Let's say, for example, I'm going to show you one of the tool which doesn't exactly fit into development methodology, but development tools, but we'll still use it by having another wrapper on top of it to make it work, right? So use that, and then the earlier the security, the better. So the more we should start working on security from requirements phase, and then in the design phase, to implementation phase, and until it goes into production, right? So that's exactly is what this diagram talks about, the Microsoft Secure SDLC process. Like, here you have in every stage of SDLC, you have some requirements. Like, here in the requirement phase, you're going to establish security requirements, and then you're going to create gates, basically. And I'm going to show you now after this how we can create gates, right, by a demo. And then you can establish requirements, and then you can also figure out what kind of attack surface this application has, and then do a threat modeling as well. And most of it can be automated, but let's say there is dynamic analysis. Not all cases can be automated in there. So we'll see. So we'll put only the tools which can capture low-hanging fruits. For example, there's a configuration issue, then we can figure that out. But business logic bugs cannot be found in this entire pipeline. So you have to have. So we are not saying here also that we are not replacing a security person. We are just taking out his burden, because right now, security guys manage close to like 500 systems alone. Right? just that. And if your developers are pushing every minute, then it becomes even more scarier, because you usually only have like one security person for 100 developers. So you cannot technically handle that kind of a load. So DevSecOps pipeline will help you have some confidence that, okay, even if the developers are pushing code very rapidly, you still are secure, right? And so one common question which I usually get is that, hey, Imran, this does not work in my organization because there's a lot of processes to follow. There's a lot of approvals to be taken and all those things, right? So we can automate all those approval process as well, right? So in the next talk, I'm going to show you how we can automatically deploy to production by sending a two-factor authentication to his manager, or approval to his manager. So when his manager clicks the button, says yes in the Slack, then it goes to production. Otherwise, it won't go to production. Something like that. So, and then you can also implement the similar methodology for security guys as well, right? So with that, let's go ahead and talk about the implementation, the demo part of it. Like how do I start implementing this, right? So what we do here is that, like, this is a traditional DevOps pipeline where you have a code in GitHub repository. So it doesn't matter if you're using a GitHub Enterprise or you have a Git local server, or it doesn't matter if you're using Jenkins, Travis, or any other like TeamCity as well. So then you run on there unit test, integration test, code analysis. This is exactly the same thing which we discussed here, but in diagrammatic format, right? So now in here, in every stage, we will now embed security, like us. So yeah, so let's get down into let me explain this first. Okay, so we will embed security in here, and then the tools will run, and then you will supplement that with a manual assessment as well. Let's say there are a few vulnerabilities you cannot find automatically, or there are false positives. Then a person does a manual assessment, and then he says yes or no, and then it moves to the further down the chain of SDLC. And here you can embed like tons of tools. So I'm going to show you 3 tools today. Okay, so one is your static analysis. So as soon as you push your code to production, on every commit, okay, the scans will run. The static analysis scans will run, and they will be filed in your Jira or any issue management system, Bugzilla, Jira, or whatever. And then we'll also talk. We'll see now how to automate third-party components. Let's say the recent hack, Equifax, they got hacked because of Strux, right? Strux vulnerability. Now we'll put that also as part of your pipeline, CI/CD pipeline, so you can figure that out much before you got hacked or something like that, right? And then we'll also see in the next iteration. So I'm going to talk only about those 2 now, but we'll also see how to embed SAP proxy, or let's say bug proxy in it, or IBM AppScan, or checkmarks for that matter. Any tool which you are using. I just want to show you. Most people, when it comes to DevSecOps, they only show the open source tools because it's easy to do and they're easily available and you can try it. But I will also show you how to do that similar thing with proprietary tools as well, like checkmarks, or source clear, or white source. Okay, so that's there. And then we'll also talk about vulnerability management, and then how to triage it, and how to generate metrics, like what's your mean time to remediate in your organization, and then how to automatically follow through the developer saying that, hey, your vulnerability is being in the triage for like X days. You need please give me an update. So we'll automate all of that as well, right? So with that, let's go ahead and see a demo now. Okay, so before that, any questions before we move to demos? Okay, great. So in here, I have so this is one of a project, okay? This is a Python project. And you have a Django project in here, which uses bunch of third-party components like npm packages, Bower packages, and then you also have a bunch of Python packages like Django, uh, you know, uh, PostgreSQL, and many more things. Like you see all of these like RESTful framework, pigments, request, and all those things, right? So what we'll do now is that we will embed now security as part of it. So it doesn't right now, it doesn't have any security built into it. Okay, so there's nothing of security in here. So we are going to put security in it as part of CI/CD process. Now, usually you see people talking about Jenkins, right? So which is like an in-house on-premise solution to automate your CI/CD. But for today's case, I'm going to show you on a tool called Travis. Okay, so this is a free tool for open source projects. So I'm going to show you, and if you fork my project here, then you can do similar stuff, and then sign up, and then it will allow you to run these things. So if you see here, I started off here. So I'm going to start from scratch, but I'm going to show you what's our end goal, right? So I started from without having integration. So I added Travis integration here, and then added Bandit. Bandit is our static analysis tool, just like your find bugs, check marks, or IBM source version, source code scan, or 45 for that matter. And Ruby has something called Brakeman, Node, PHP has rips. So you can embed any of those tools. I'm just showing a one demo, which is not conventional in the things, right? Usually you see people doing it in, doing it for Java, right? So we are going to start from scratch and do something else, right? So I'm going to go into this. I've already cloned this one. As you can see, I'm in this branch right now. So let me go back to master branch, and you see there is no Travis file here. There is no security of any kind in here. Okay, there's no Travis file here if you see. Okay, so what we'll do now is that, well, okay, hold on. Yeah, so we will now add Travis integration, which is like your Jenkins, right? So every time you push a commit to your GitHub, then there would be a scan running, like static analysis, dynamic analysis, or open source. So let me create another branch now, so that we keep this data intact. If something goes wrong, we can always go back. So check out, and we'll say DSO, right? Demo. And as you can see, we are in now DSO branch, and this is exactly the same branch we had before. Like there's no changes in here, right? So let's add a file called Travis. This is the file which Travis looks for when it's doing when we push the code to it. So let's go ahead and see that particular branch so that we can quickly copy paste it. I don't want to waste your time in typing things, right? So yeah, so this is the file. So we're going to copy this exactly like that, and then paste it here. Okay, right, and then yeah, so I'm not going to run this particular right now. I'm going to disable it, so so that I can show you that these tools are, even if these tools are non-existent, it will still work. Okay, so let's do this. Hold on. Yeah, so let's do that. So let me add this to, yeah. So I'm just saying, hey, I'm add Travis to code. I could be more verbose, but I'm just don't want to waste your time, so I'm just doing it. Okay. So right now, if you go look at our Travis now, which is just like Jenkins, so that you, right? So there's only one branch right now, which we are pushing to. But as soon as I push this, there would be a job will be running, right? Okay, so I'll just paste that. I'm not doing anything fancy. I'm just following the instructions. Okay. Okay, I pushed it. Now, the usual workflow is that now the developer related queries will run now. You see it as this is exactly the same commit message I said. Right? And because we had two environment variables in there, it's running, but it's going to run exactly the same job right now because we haven't integrated those tools in it. All right. So what it's doing is that it's cloning the Git repository, and as you can see, it's in this branch. Then it's setting up some API configuration details, and it's installing some Python packages because it's a Python-based project. But since there is no security tools embedded in this one, it will just exit after this. Like, yeah, I've successfully built the project, and we are good to go. Yeah, so let's come back here, and then you can see the status. Like, okay, so this has been running from past 1 minute, and this will turn green now. If everything goes good, this will be green. And if there is a green checkbox in here, that means that it's safe to push to next stage. Could be integration tests, or it could be that one, other things. That looks like that it failed, right? Something happened and it failed. So let's figure out what happened. Right? Yeah, so it's complaining that there is no script tag in here, and that's why I cannot run anything. But you just add the script tag in there, and then we are good to go. So let's edit that. Right. So, and I'm deliberately showing you this errors because to show that this is not rocket science, and you just have to. The way this works is just trial and error. Like, go see if it's working, then fine. If it's not, then you iterate and then do it. Okay. So I'm just pushing again code. Right. Okay. So now you should see that there would be another scan now, which will kick off in a second. There you go. Now this will work. Okay. So let it run. Meanwhile, let's talk about what I'm doing here. Okay. So what we are saying here is just basically once you download the code, this is the Python code, and this is version 2.7 of Python. And then I'm saying, hey, install all the packages. Usually requirements.txt has all the packages in there. And then we're saying, okay, so once you install the packages and it's ready, and usually you will also have a unit test cases or integration test cases, but I just skip them to make it faster, make the build faster. And then here you're so I included one open source tool and one proprietary tool. And the reason why I did was last time when I did this session in Null Singapore, one of the guys said, hey, Imran, all of this is good, but this only works for open source tools. It will not work for proprietary tools. So I wanted to include one proprietary tool in here, but you can also use like OWASP dependency checker in case of source clear and other things. It's pretty easy to, okay. So as you can see, I did not lie. It's working fine now, right? So then next thing what I will do is that I will add those two other two scripts in here. So one of that was source clear, right? So this is the code in there, okay? And the only thing which we have to look right now is just this. I just added only that snippet, which is doing the scan. The rest of it is all error checking, like making sure there is a token available, making sure if the website is down, I'm just saying, hey, exit it if the website is down, okay? So I'll copy this code, and then I will put in the Travis And okay, I have to create a script directory, and then script source clear, right? I'm just pasting that code here. Okay. Now we'll now go ahead and add this to this one, and we also have to change our Travis to make sure that it runs this as well, right? Now, because we did not integrate Bandit yet, it will fail, which is okay, but source clear will pass. Okay, let's go ahead and add Travis to the Git. Now, let's add source clear, push. Okay. Now, what this will do right now is that it will find out all third-party components which we're using, like Node.js packages, like are we using vulnerable version of Ajax, Bootstrap, or any such third-party tool, or if you're using, let's say, stocks, this will work for any, any language. It could be Python, Ruby on Rails, Java, .NET as well, right? So let's go ahead and see. As you can see, the add source clear started running, and this is happening for each and every commit now, right? I didn't do anything. The only thing which I've done though is that I went ahead here, and in here I just enabled this tick box. That's it. That's the only thing you have to do to integrate Travis with your GitHub project. Right? Much easier to do than Jenkins. But Jenkins provides lots of flexibility in-house, and you don't have to pay anything. So we will also see that, but not today, right? So yeah, okay. So there's some error which says permission denied. Oh boy, what happened? Right? So there's some issue in there. And you know what? I know exactly why it did not work. Because if you look at the previous history here, here I'll say that fix permissions here, right? Because we didn't give executable permission to source clear. So it will not run. Even though we added it, but it will not run, right? So I think this is the last thing which I show trial and error, because I think you got the point that, hey, just do a trial and error, figure out what's working and what doesn't. Okay. Right. So yeah, this also started working. Let's go ahead and see if this can complete. So it's doing all its stuff. You don't have to know all of it. This looks more like a code based, right? Jenkins is like point and click. You point. So I'll show you that as well. So you can do exactly the same things in Jenkins as well. Okay, go back. Yeah, and if you see, all of these are finishing in just like 2 minutes and 7 minutes. And this is one of the other best practices we should follow, is that if a tool takes more than 10 minutes, don't put them in this pipeline, because the deployments will be delayed and it's not worth doing. And probably they will give us a lot of false positives, or developers don't have patience to do it, right? So you should only run the tools which will give you results faster, and then also they're easy to understand by the developers, right? So let's see. Okay, it seems to be working now, and you can see that it started scanning, and it's scanning power, npm, and then other packages, npm packages. So we can yeah. And we'll also see the output in here, so that now developers can go ahead and fix it as while they are developing. So if you look at it, it did not go to production. I did not merge it with master branch. So it's still in the development phase. And for everything they do, and you can see that we have like bunch of high risk vulnerabilities, medium risk, and all those. So you now have to go fix them and then make this work, right? So you also have like a dashboard in here. Yeah, dashboard in here. I hope I remember the password. Okay, but yeah, I'll show you. I have to figure out my password. I have to generate it, right? So that's the one thing. And then you can also, similarly, you can also add, uh, static analysis as well, which I'm not going to show because of time constraints, but I will show you the previous version of it. Build history, you can see here that I added, and it's a working version. It's a green, right? So now source clear will run in its own job, and the bandit, which is a static analysis tool, will run in its own job. So you know if some build fails, it's because of third-party components or it's because of static analysis. As you can see here, the bandit started running, which is static analysis code tool. And then you can see, hey, I found out a vulnerability. The vulnerability is this: use of mark save will lead to cross-site scripting attacks, so you should remove it. And you also have a code snippet which says where exactly the issue is, right? And then the developers can go fix it, okay? And another thing, interesting thing, which you could do is that you can fail the builds so that developers don't push to production if there is a vulnerability. So I have added a file here called fail on high. So if I find high vulnerability, high severity vulnerabilities, my builds will fail now. So, right, so let me add that. Okay, added. Then say fail on high severity issues, right? Then push. Now, if you notice, last time this was green, right? Now this time this will be red because we, as you saw, we had high severity bugs and we don't want them to go to production. So you have all that flexibility even for Bandit or any such tools. You have it. If you don't have one, then you can create one. It's pretty easy, and most often it's just Googling around. So you Google and someone have already done that work for you. So you copy that script and put it in your code, and boom, you have it. Or let's say you are a security professional, but you don't know how to code or don't have even a remote idea of how it's done. Then what you can do is that go talk to a developer, say, hey, this is what I want to accomplish. Can you help me do it? And they would be more than happy. And if you look at the code, it was just like few lines. It's not huge, right? So yeah, let's go back and see if things are working fine. We still need to give 1 more minute to it. All right. So meanwhile, any other questions? So I'll put all of these on GitHub repositories, so you can just pull the code and you can start doing all of this on your own. So you have idea. So as you can see, this passed, but now that I have made that this has to fail if there is high severity vulnerabilities. As you can see, it failed, right? Yeah, there you go. So we now stop developers from pushing malicious or bad code, for that matter, vulnerable code to production, right? And every time you do something like this, there would be an email sent to you saying that, hey, there's a build failing, there is fixed and broken. So even security team can accept those notifications, and then they can work on it. And it's pretty easy to do. So you have all the workflow of have a pull request, then merge it to production, merge it to master production branch, all those things, right? So that's like just a gist of automation, CI/CD automation, but there's more to it than just these tools, right? Probably in the next, because this was introduction, I had to talk a lot about theory as well, but the next iterations we'll talk more about what should be your strategies, how should you approach your senior management to try doing this, or how should you evaluate the tools before you purchase. So you know that they will work seamlessly as part of your development pipelines, right? Okay, so far we did kind of this one, not exactly like we have used approved tools probably, like for my organization, SourceClear is approved tool and Bandit is approved tool, but for yours it could be different. 45 AppScan, whatever. Our open source tools are great. As of Brakeman is awesome if you're using Ruby on Rails, so that's there. Riffs also is pretty good for PHP. You can use that as well, but I'm not endorsing them, but they're good enough for them being free. They're open source, and definitely Zap, check out Zap. And then we figured out like the APIs which we are using, which is third-party components. We figured that out as well. And then we also did a static analysis as well, right? So if you're saying we did not do it, I can I can just restart this job, the previous job, which was successful, which was here, right? I can go here and then restart it so you can see it's working. It's not a stale version. Okay, so I'll show you in a minute. Okay, go back to here, presentation. Yeah, so we did static analysis as well. Right. So this is there is a nice project on OWASP called AppSec pipeline, which talks about how a pipeline could look like. For example, here it's triage, test, and deliver stage of your pipeline. And then they also gave a kind of example wherein they're using these tools like Checkmarks, Veracode, Bugsuite, White Hat, IBM, and all of these can be integrated as part of your CI/CD. There could be a lot of other tools as well. And then as soon as the scans are finished, you directly assign the ticket to the developer. And the way you do it is basically, if you go to GitHub, right, you know exactly who pushed it. So you know, okay, who's gonna fix it is this guy. So you don't have to bother about, okay, who's gonna fix it now, right? Whom to approach. It's straightforward. Assign it to whoever is there, whoever pushed this code to production, and it's his responsibility, which is the culture part of it. Whoever pushes code to production, it's his responsibility to fix the code as well, right? And then we can obviously do metrics based on Travis, based on GitHub, all those nice fancy things you can do. And then, yeah, so I think I'll stop here. But before I stop, I will give you a teaser of what was the other demo which I couldn't cover. So I'm starting a project called Practical DevSecOps, which will create like virtual machines, right? Which you can download in your system and then play with all these setups. So the setup will automatically come up when you start, when you say Vagrant up. This entire setup will come, and then you can play around with it. Okay, so just to give a brief of it, what this does is that, let's say when you install like Kali, you download a Kali ISO and then you install it. How long does it take? Like you press Ubuntu installation next button, and then probably like 15 minutes or so. But by using Vagrant, you can deploy like 15 machines probably in just 3 minutes. Right? It's pretty fast to do that. And the way you do is by using a technique called infrastructure as code. So your entire system would be your code. Like as you can see here, I'm using Ubuntu 16.04. I'm giving it an IP address. I'm managing memory here. Like I'm saying, hey, give it 512 memory to this one. For the Jenkins, I want you to give 512. I'm setting up ports, port forwarding, all those things which you do manually, button clicks, you can automate using Vagrant, right? So right now, I have a few machines running, which I can show you by this command called Vagrant status, right? As you can see, there are like 5 machines running, and all I did to run all of these machines was just Vagrant up after creating that Vagrant file. Now, to show that I'm not just bluffing, what I'll do is I'll add 2 more machines to here, like in this code. It's just I created a for loop and added like which one. So if you look at now Vagrant status, there will be now web 2, 3, and 4. As you can see, these two machines popped up, but they are not running and they're not created. And to create them is just specifically vagrant up. That's it. And it will start, as you can see, it's provisioning them, and it's also started provisioning this box here. So other demo which I had was like how to harden it automatically. But what I will do now is that, because we ran out of time, I'll just push it to production. I'm sorry, on the GitHub repository, Practical DevOps. You can push and play around with it, and then in the next session we'll see how to harden your infrastructure by just click of a button. And how do you put that in Jenkins or Travis so the hardening happens automatically without anyone's involvement. So the workflow looks like is that someone creates a machine on production, then you will get an alert, and then that alert will kickstart the hardening process. So your production machine will always be hardened and always be up to date, because we'll set cron jobs and all those fancy things, right? Now, if you look at VirtualBox now, I'm just using VirtualBox because it's free and you can try that out. As you can see, this is running right now. So Web 3 and Web 4, but we have automated it, and it's running as a infrastructure as code. So, and this goes into your GitHub, and if anyone makes any changes or introduces a loophole, security loophole, you can catch him and then say, hey, why did you do this? You're opening up a firewall, so you can now audit and you get speed, reliability, all those fancy things which I talked about as part of the presentation. Okay, so this was the setup which I wanted to talk about, but since we ran out of time, I think we will stop here. Any questions before we close the call?
Hey Imran, yep. There are a couple of questions. So
okay.
One is like, how are we planning to cover in series of sessions? Maybe I'll give you a brief. So I mean, like, I'll just update a brief, and after that, like, you can continue with that. So we are planning to do and host the sessions in the same way what we are doing today. So maybe with the timeline gap of, again, like a week or a couple of weeks, or based on the availability of speaker, we'll be having the second part of session of this. And any comments on this, Imran?
Yeah, sounds good to me.
Okay. So, and also maybe you can elaborate a brief, like how we are planning to cover up in the next sessions, or like what will be the covered. So one of the attendees is very much interested on that.
Okay. So these are some of the, as I mentioned before we started this talk, is that we are going to cover all these tools. But again, I was mentioning tools are not important; they are replaceable. And but again, if you're interested, like how do you automate all of that? Is Vagrant. We're going to talk about Docker. How do you automate so Vagrant is specifically used for automating your development environment. So we'll see how to automate your production environment using something called Terraform and also Spinnaker. Okay, so your entire infrastructure will live in GitHub repository, basically. So yeah, and then we'll also see how to manage secrets, because you're on cloud, on-premise or cloud solution. So you make sure that you fit. Let's say your company is conventional, pretty old school. Then they can still be old school and use cloud. So we'll make sure that happens. Or if your company is more like a SaaS product, you can still use all of these tools. So we'll talk about that as well as part of that. And you can see here we are covering lots of things, like how to automate initial threat modeling, like 101 threat modeling, not the manual process of it. Dynamic analysis like ZAP and all, not the full-blown pen testing as such. We'll cover briefly AWS services, runtime analysis, vulnerability management, patch management, like how do you patch your Windows boxes which are in production without having any downtime, right? Phoenix methodology. And then how to how to set up a SOC operation using free tools like Elasticsearch, Logstash, and Kibana. metrics as well. Does that answer your question? Is that enough, Raghu?
I think it should be good enough. So,
Yeah.
and last call. So, do anyone have any other questions?
Okay, thanks. That's it. And I hope all of you have learned something new, and it was good use of your time. Yeah, thanks a lot for your time, and have a
Yep. Thank you, Imran, and thank you everyone for attending the session. So, we are signing off for today. Bye, guys.